Okay, in this lesson I'm going to talk about the two main reactions of esters. And the two main reactions that we are going to talk about, or the only two you need to know, are ester, hydrolysis. Now the word ester is important here because we've talked about acetal hydrolysis before, and we're going to talk about amide hydrolysis later. So you have to specify what you're talking about. So this is ester hydrolysis specifically. And the other one is saponification. Now, the cool thing is, if you know one, you know the other. So they're both going to be pretty straightforward. So if you know one, you'll know the other because they're really, you get almost the same products out of each. So, ester hydrolysis, literally ester hydrolysis is the reverse of esterification. So remember, esterification is where you take a carboxylic acid and you add an alcohol. It's an equilibrium. You add it with H+, and then you get out an ester and water. This is esterification. Ester hydrolysis is literally, so this is ester hydrolysis down here. You take an ester, R1, you add water and an acid catalyst, and you get a carboxylic acid and an alcohol. So it's literally exactly the reverse. So remember, this is an equilibrium just like esterification is an equilibrium. So remember, before I said esterification slightly favors the reactant, or the products. So to get that to happen, you either take out one of the products like water or you add the excess alcohol. Now, think about for a moment what you would do to favor the products of an ester hydrolysis. That's right, you could either remove the alcohol, or probably easier, flood the system with water. If you flood the system with water, then you get the carboxylic acid and the alcohol. So, it's the opposite of esterification. It requires a strong acid catalyst or an enzyme. We'll talk about enzymes later. So here we go. Here's the basic idea. So let me give you a more specific example before we go on and do some practice. But if I had something like, oops. Something like this. There we go. All back in order. And this. Well, then what happens is if I add water and an acid catalyst, then what I get is I break it back down into, I'm going to put them up here, into ethanol. Right? Here's where I'm getting ethanol from. Right? Here. Plus, and I guess maybe to be consistent with how I've been doing it, I'll say this is the alcohol, and we're going to stick the OH onto here. And then the rest is simply the carboxylic acid, and we give the hydrogen to the oxygen there, so it becomes this. We simply go back to the component parts. So, take a moment, draw the reaction, the products of the reactants when hydrolyzed. So realize that each one of these, we're adding water, just to make perfectly clear, we're adding water. So go ahead and pause it when you're ready, and then we'll do each one in turn. Okay, so the first one, I'm going to do this one first, I'm going to get a structure that looks like this. This is going to be my acid part. I'm literally just taking this and shoving a hydrogen here. And then I'm taking this and sticking OH on here, so I get ethanol. I'm just drawing it this way. CH2. Hopefully that makes sense. Okay, second one. We're going to get this. Again, literally just taking this part and shoving a hydrogen onto here, and then taking this part, CH3, CH3. I'm literally just going to stick an OH here where it was bonded to the oxygen. So this is OH, like that. And then in this part, I'm going to take this one. So here's my acid. Actually, I'm going to try converting this. I'm going to convert this one into. I'm going to draw this one as line angle diagrams. So I've got my 2 carbons, so 1, 2, 1, 2, and then I've got OH, so 1, 2 here. And finally, the last one. I'm going to get, I'll do line angle drawings on this one too. Right, so here's my carbon 1, carbon 2 in the methyl group. Carbon, oh, I drew them wrong. I mean, numbered them wrong. 1, 2, 3 in the methyl group, so 1, 2, 3, and then the methyl group there, and then I put an H here, and then my alcohol is simply just going to be phenol. This is this, OH. And that's all there is to it. So hydrolysis should be one of the easier reactions to see because it's literally just snapping the molecule into 2 parts. So let's talk about saponification now. Saponification is, so ester hydrolysis requires an acid to happen. You have to have an acid to make that happen. The hydrolysis of this can happen in a basic solution as well. So saponification is if we add a base. It doesn't have to be sodium hydroxide, but sodium hydroxide is a nice, common, easy one to work with. And what it does is we get exactly the same products. We get the same alcohol here, over here. The only difference is we get a carboxylic acid salt, or carboxylate salt. So here we get the salt, right, because the solution is basic. And what that does in a basic solution, the base comes along and it grabs the proton and takes it away from any acids that are hanging out. Acids don't hang onto the protons well. So what we get is we get a negative ion. So anytime you have a basic solution, you're going to end up with a carboxylate ion. So because it's base catalyzed, well, it's actually not catalyzed, but it's a reaction with the base, you get the carboxylate ion, and because there's the sodium here, you get the carboxylate salt of sodium. So a reaction, an example of that, I'm going to go ahead and use the same example I used before. I think it was the same example. I'm not sure. What the? I think it was this. I'm not really sure. I'm going to get 2 parts again. I'm going to get an alcohol, but this time I'm going to get a salt. So let me show that salt that we get. I'm going to show both of these. So what happens is when I react these with, let's do potassium hydroxide instead, and go up here. It's hard to tell from my big weird arrow here, but whereas hydrolysis is an equilibrium, saponification is not. The strong base forces the reaction all the way to the right, so it goes all the way to the product. And so what we get is, I'm going to draw the alcohol part first because that's pretty self-explanatory. Now we get the alcohol, it's the same. But what we get instead is I get the same product over here, but the only difference is that OH isn't there. It gets ripped off, and instead we get a minus, but because there's this potassium hanging around, we get K+. So we get, this would be potassium 2-methyl propanoate. So, and there it is, and that's saponification. So, the same 4 compounds we used before, we're going to have these undergo saponification using sodium hydroxide. So each one's going to have NaOH added to it. So the first one, we get the same alcohol. What's different is that we get this compound. So if you understand hydrolysis, saponification should be simple. The second one, we're going to get this alcohol here. And then we're going to get a carboxylate salt with sodium. Now we're getting sodium on here because it's reacting with sodium hydroxide. If we're reacting with something else, potassium hydroxide or something else, we would get a different cation attached. This one, we're going to get ethanol from here, right? Excuse me, from here. And then we're going to get this part, and because it's saponification, you get that. And the final one, I'm going to get phenol, but I'm also going to get this carboxylate salt here. And there it is. And that's it. That's all I need. That's all you need to know.